Welcome back to Code Meets World. Today we're looking at LeetCode problem number 36, Valid Sudoku. So this problem says, determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 through 9 without repeating. Each column contains 1 through 9 without repeating. And each of the 9 3x3 boxes must also contain 1 through 9. None of these can repeat. Okay, so I love Sudokus, so this will be really fun. If you don't solve Sudokus, A, I really recommend it because they're super fun. But B, what this problem's asking us to do is, given a board, we have to see if it's valid, meaning are there any duplicates in any of the rows, any of the columns, or any of the boxes. Down here, we see what the input is going to look like for the program, which is just a giant two-dimensional array where the digits are just numbers and the empty values are dots. And it looks like all of this is input as a string. And in this case, we need to return true because I guess this is a valid board. And in this case, it's an 8 instead, which means there is duplicates. So if this value right here is an 8, there's two problems. This column would have two 8s in it, and this box would have two 8s in it. So for both of those reasons, we would return false because this is not a valid Sudoku. Here I have the Sudoku board from the problem description, and we're going to talk about how we can solve this. One way that we could do it, which would be really, really slow, but it would work, is we could loop over every single cell in the entire Sudoku. So starting here with the 5, we could say, all right, are there any other 5s in this box? Are there any other 5s in this row? And are there any other 5s in that column? So we could check all three of those, and if there are any 5s in any of those three spots, we could return false. And then after we check that spot, we could go and check the 3 and check again. Are there any 3s here? Are there any 3s here? And are there any 3s here? We could do this for every value, but that means that for every value in the entire Sudoku, we would have to check the whole row, the whole column, and the whole box, and that's not super efficient. Even though the Sudokus are set at 3x3 grids, it wouldn't be terribly slow because the Sudoku is so small, but it's not the best solution that we could come up with. A better solution would be if we think back to problems that we've looked at before, where we're checking for duplicates in some sort of data structure, and we use a set to keep track of what we've seen. I think we can use a similar concept here, except we need to keep track of not just the value, but its position in the Sudoku. So let's think about that. Every single value in the Sudoku has 3 different locations. It has a row, it has a column, and it has a box, right? And what we can do is create one giant set and input into that set, at each square that we see, all 3 of its positions. So let me show you an example with this 5 here. So this 5 is in row 0 if we use Python indexing, which starts at 0. So it's at row 0, it's at column 0, and it's in box, if we label, this is box 0, 1, 2, box 3, 4, 5, etc. This is box 0. Obviously, all 3 of these end up being 0, which isn't very helpful because we don't know which goes with which. So what we could do is append an R to the beginning of row, a C to the beginning of column, and a B to the beginning of box. And then we can store all 3 of these in the set. So our set would have R0, C0, and B0. as strings like that. And the reason that we would do this is because now, if, say, we encountered a 5 later on, say there was a 5 in that position in the box, then when we go to define what are the values for that, well, this one's in column, oh, you know what? We actually need to add one more thing to our markers, which is the actual value that's there. So if I remove these, we also need to keep track of the value. So 5. There's a 5 in row 0, there is a 5 in column 0, and there is a 5 in box 0. And then down here, these would have 5s in front of them, like that. Right, that's important. So now this makes a lot more sense. If we see a 5 in the same box, the values for this are, there's a 5 in row 1, there's a 5 in column 2, so row 1, column 2, and there is a 5 in box 0. So then when we go to add these to the set, we would check 5 row 1, that's not there, so we would add 5 row 1. We would do 5 in column 2, so 5 column 2. But then here, when we check for 5B0, we have a 5B0 already, which means we have a duplicate in a box, and we would return false. This Sudoku is not valid. So basically, what we're going to do here is loop over every value in the Sudoku, compute these 3 location identifiers for that value. We're going to check if any of them are in a set, and if they are, we can return false because we have a duplicate. And if they aren't in the set, we will add them to the set and then continue on to the next value. And if we do this, we only have to loop through every value in the Sudoku one single time and just calculate 3 positions at each one. So the first thing that we'll do is create that set that we have been using, and I'll call it scene, and I'll set that equal to an empty set. The next thing we need to do is, like we talked about, we're just going to loop over every cell in the entire Sudoku board. So to do that, we're given a 2D array called board. So we can say for row, and this will be the row number. So for row, board row, and this will be the actual row because I'm going to use enumerate. And remember, when we use enumerate, this is the index and this is the actual value or the object. So we're enumerating over board. So this is all of the rows. And then we need to loop over all the columns as well. So we can say column, and this will be the column value. This is the row number and the column number because those are the indexes. And then this is the row object, and this will be the actual number in the Sudoku because we will say enumerate row, board row, like that. One thing I didn't talk about, I guess, is what to do with these dots, because if we see a dot, we obviously don't want to add that to the set because we only care about the numbers. So I guess if the value we see is a dot, we can just skip over it and continue processing, right? Because if we see a dot, it doesn't really matter. It's not going to impact any of the duplicate calculations we're doing. So if we see a dot, we'll just do continue, which will just skip over this box and move to the next one. The next thing that we need to do is compute what I talked about on the whiteboard, which is the identifier, the location that we're going to compute. And we need to make 3 of them for every single value that we see in the Sudoku because it has a row, a column, and a box. So I think the way I'm going to do that is by creating an array that builds each of the 3 location markers that we need. So let me show you what I mean by that. So first, I'm going to make an array that calculates these three things. So the row, the column, and the box string. And then I'll loop over this array and add the value in a second. So first the row, which is going to be the string r plus, and then the actual row number, which is this value here. So we have to convert that to a string like this. So that is the row number. The column number will be exactly the same. It'll be C for column plus str column, which is this index here. And then finally, we need the box, which is going to be B plus str. And then as you can see, I don't have a box index. So I've been thinking about how I might do this, how to compute what box that we're at given the row and the column. And one thing that we could certainly do is write a bunch of if statements and say if, what would it be? If row is less than or equal to 2 and column is less than or equal to 2, we're in this first box. If row is less than or equal to 2 and columns less than or equal to 5, we'd be in this box. But that's going to be a lot of if statements. I think what I'm going to do instead is actually make a board map and set that equal to an array. And I'm just going to fill in a 9x9 grid where the value is what box we are in. So for instance, this first one would be 0, 0, 0, 1, 1, 1, 2, 2, 2. Does that make sense? In this first row here, if we're in any of these three, that's box 0. If we're any of these three, that's box 1. And if we're any of these three, that's box 2. So hopefully that makes sense. So this map will tell us, given any row and column, it'll tell us what box we are. And the reason I'm hard coding this is because I think it's going to be faster and easier to write than a bunch of if statements. And because it's not that much space, it's only 81 values, I think it's worth doing. So then we need a function, and I'll call it getBox, that actually returns the correct value. So given a row and a column, this thing will just return board map, and that will be a row column. And so given a row and a column value, this will just go into here and return the value that's at that location. So now down here, we can say get box, and then we can just pass this the row and the column that we already have, and then we append that to B, and now we have all three of these. We can loop over each of these locations. So for location in locations, the entry that we want to compute is equal to the value. Now we're computing, so remember, we just made these, the row, column, and box. Now we need to include the value at the beginning of them so that we get value, row, column, or box, and then the value that that's in. So we'll take the value, so the actual number, make that a string. We will add that to the value here. So we basically are putting the number in front of each of these. And then we can ask, is entry in seen? So have we seen this value before in our set? If we have, there's a duplicate. So we can return false in that case. If we haven't seen it, we just need to add it into the set so that we can look for it later. And we can do that by saying seen.add this entry. And at the very end, if we go through the entire for loop, all 81 values, and we never see a duplicate, well, in that case, we can return true. So let's run this. See if we made any mistakes. So that has passed the 2 test cases that were given. And there we go. That solution works. It's right in the block of typical solutions. It's pretty quick. The only reason it's not better on memory is because I've used this extra block instead of a bunch of if statements, but to me, this is more readable and makes a lot more intuitive sense. So this was a really fun problem, and thanks so much for watching. See you in the next video.